and comments need.
Hi guys, welcome to my YouTube channel. This video is all about transformer short circuit test calculations and how to do it practically. For example, let's consider a transformer of rating kVA rating of 10 MVA. Its HV voltage is equal to 33 kV. LV voltage equal to 11 kV, and the given percentage impedance is equal to 6.81 percentage. We all know that formula for power is P equal to root 3 VI cos phi for three-phase supply. Since power factor is not considered in the transformer, it will be P equal to root 3 VI. Here from the given nameplate details we don't know the current, so we know the power. So if you substitute it in the formula, I equal to 10 MVA, 10 into 10 to the power of 3 into 10 to the power of 3, total 10 to the power of 6, divided by root 3 into V, 33 kV, into 10 to the power of 3, 33,000, which this cancels. So the value we are getting will be 174.95 amps. So this is the I primary full load current. This is the primary full load current. Actually, primary and secondary full load current will be mentioned by the manufacturer in the nameplate itself. Or you can use another formula also for finding this current, HV current. HV current equal to kVA into 1000 divided by root 3 into HV voltage. Anyway, both are same formula. Okay, we have find out primary full load current. Then how to find out secondary full load current of transformer. To find out secondary full load current, we are going to use the formula V1 by V2 equal to I2 by I1. We know I1, V1, V2. By substituting this, I2 equal to V1 is 33,000, V2 is how much? 11,000 into I1. We have calculated it 74.95. So by substituting it, and you will get I secondary full load current as something like 524.85 amps. This is transformer primary full load current, and this is transformer secondary full load current. Now actually it will be mentioned in the, as I said previously, it will be mentioned in the nameplate details. I have shown these formulas. If it is not mentioned in the nameplate details, we can find it easily by using these formulas. So for calculating short circuit current, first we have to find impedance voltage. The formula for calculating impedance voltage equal to rated HV voltage into percentage impedance. Here our rated HV voltage is 33,000 and percentage impedance is 6.81. Since it is percentage, we put divided by 100. If you solve this, you will get 2247.3 voltage. This is impedance voltage. Actually, out of this 33,000 voltage, this 2247.3 is enough to circulate secondary full load current when it is shorted. Means this 2247.3 voltage is sufficient to circulate the secondary full load current when it is shorted. So now we are going to check it practically. This is our calculated values. Oh, still we have to calculate this. We are going to apply 415 voltages. Our available testing voltage at site is 415 voltages. So we are going to apply 415 voltages in primary of the transformer, and we are going to short the secondary of the transformer. Before that, if we apply 415 voltages, we have to know that how much current will flow in primary and secondary of the transformer. How to find it? For this one, the formula is HV current equal to applied voltage into rated current divided by percentage impedance into rated voltage into 100. This is nothing but impedance voltage. So we are going to apply 415 voltage. So applied voltage, don't confuse with this. I have written here HV current. Before we have found out HV full load current of the transformer. Now we are going to find out the current which will flow when we apply 415 voltages. Okay, so applied voltage is, we are applying 415 volt in rated current. What we have found out is 174.95 rated current, which is rated primary full load current, divided by impedance. This is not, as I told, this is nothing but impedance voltage. Previously I have calculated as 2247.3. So you will get, if you derive it, you will get 32.30 amps. This much current will flow in primary if we will apply 415 voltage by keeping the secondary shorted. Okay, then how to find out the LV current while applying 415 voltage? By using the same formula, V1 by V2 equal to I2 by I1. I1 we know that is equal to 33,000 divided by 11,000 equal to I2 by I1 we know 32.30. So we will get something like 96.9 amps. This is the LV current. This is the HV current. So our if you apply 415 voltages by keeping the transformer secondary shorted, we will get, this is our calculated value, we will get 32.30 amps in the HV side and 96.9 amps in the secondary side. This is our calculated value. We have to test it practically. Again, to check whether we have calculated this current is calculation is correct or not, Let's substitute this obtained values in percentage impedance formula. Impedance formula equal to applied voltage into rated current divided by measured current. Shared current into rated HV voltage into 100. So your applied voltage is 415 voltages and rated current is rated full load current of transformer primary, and 95 divided by measured current. What you have measured? What you have measured is the primary current we have measured here is 32.30 while applying this 415 voltage into rated HV voltages is 33 on 2000. So it will come around 72604.25 by 10.9. We'll get percentage impedance equal to 6.81. This is what mentioned in the nameplate of the transformer. Or if percentage impedance is not given in the transformer nameplate details, we can find it by using this formula. So again, how to obtain the calculated short circuit current practically? Let's consider delta and star. Delta star. Here this is primary, this is secondary winding of a transformer. We are going to apply 415 voltages in primary, and we are going to short the secondary side. Okay, apply 415 by keeping the transformer secondary winding shorted. Okay, again, please make sure that the shorting loop wire you are using is capable of carrying the calculated secondary current, otherwise you will face serious damages such as burnings. Then note down the primary applied voltages. You are applying 415 voltages, but again we have to note down RY, YB, BR voltages. Then measure the current in R phase, Y phase, B phase using leakage tester, and you have to measure in secondary side of the transformer also. Actually, practically, if you see, you will get exactly the same current as calculated in the primary, but if you measure it in the secondary, you will get current values nearby the calculated values. It depends upon how tightly it was connected. So, but again, if you are see, this is transformer. Star, if the secondary of the transformer is connected to a respective panel, means goes to a panel, it is connected to the, maybe it will be connected to cable or a bus deck. It depends upon the client or the designers. Okay, here it's going to be connected to a panel. So first this panel, here we will have CT. Many panels will have earth switch. Then only we will have breaker. by closing this ear switch, instead of using the looping wire, you will get the same value as calculated. You will get the same value. If this is closed, you will get the same value as calculated if you read the current in the relay through the installed measuring city. It will go to any measuring instruments like ammeter. Again, it will go to relay also. If you measure the secondary current, you will get the same value as calculated, as same value which we have calculated. Both will be same. Actually, this I found it practically while doing many short circuit tests. We won't get a exact value. Little bit plus or minus only we'll be getting. So we thought how to get the exact value, and we found out this. So this will be, I think this session will be useful to you. That's all for today's topic. Let's see in another videos. If you want me to put any videos regarding testing and commissioning, kindly let me know through your comments. Thanks for watching. Thank you.